tiempo, y entonces y además como es en español, me va a sobrar tiempo. Entonces lo ideal es que sea participativa la charla en cualquier momento, que sea una discusión. Quizá, de hecho, no me importa si no da tiempo a ver todas las diapositivas, siempre que sea enriquecedora y que nos aporte la discusión. No es porque no voy a correr para terminar de ver todo, ¿vale? Por supuesto, muchísimas gracias a los que han organizado esto y a los sponsors. Si alguna vez organizé un evento de este tipo, pero es que es un trabajo titánico, así que gracias a todo el mundo. De las cosas que quería hablaros, digamos que la mayoría están inspiradas en estos libros y en estos autores. ¿Conocéis los libros? ¿Os suena? Los autores quizás sí, algunos de ellos no. Pues claro, no hay problema, pasad. Pues son ideas que he traído principalmente de estos libros y algunos que no está ahí, y también gracias a los años de experiencia en la batalla, teniendo suerte de programar con gente de la que he aprendido mucho. Esto va sobre principios de diseño, pero no a nivel de arquitectura, de sistemas de infraestructura, sino va de que cuando uno está programando, siempre está tomando pequeñas decisiones sobre, bueno, esto aquí uso un bucle o lo hago recursivo, pongo un if else, pongo un switch o hago polimorfismo. Hay un montón de pequeñas decisiones que a veces ignoramos, que en realidad sí que estamos tomando. Y el ser consciente de ellas hace que tu código al final sea más mantenible, ¿no? Son detalles muy, muy sutiles, pero que acaban teniendo un impacto en el código. Sobre este tipo de principios es el que quería hablar. Principios del detalle pequeño de la decisión que tomas con cada línea que escribes de código. Adelante, por favor. La idea es que uno sea consciente de esas decisiones para no tomarlas de manera inconsciente y luego que las consecuencias te exploten, y que en nuestro caso sepamos explicarle a otra persona por qué tomamos esas decisiones, cuáles son nuestros principios y por qué son esos. Y el motivo por el que nos preocupa tanto a mí últimamente es porque hacemos pair programming. ¿Habéis visto el vídeo de Atlassian del Pune?
Sorry for interrupting, just a quick question. Is this talk that should be in English?
It should be in English, but before you were here, I asked a question.
So I'm the only one.
No. Then I switched to English.
No, sorry, don't bother because...
No, officially it was supposed to be in English. So we can do it in English. Thank you for letting me know. Now I'm going to be a little bit more slowly, but also, if there's anything you don't understand, any of you guys, just let me know and I'll repeat. So the way we work, I didn't introduce myself. So we are a small software company. We write software, and the way we do it is that we pair most of the time we are pairing. We are two people working together, and sometimes we are more than two people, 3, 4, or even 6 people working together. So when you want to implement your idea in a certain way, if your reason or if your argument is that I like it this way more than your way, it's really hard to find an agreement. So, and that happens very, very often because you smell that the way that your colleague is proposing is going to be a problem, but you perhaps don't know how to explain it. Why is it going to be a problem? I mean, it's a battle between I like it and you like it, so what do we do? And for this reason, we are more aware of the principles and the rationale behind our small decisions. And this is why we try to conceptualize or explain everything in a way that is logical. like if I was coding on my own, I don't have to explain anyone why am I choosing this way or the other way. But when you are pairing, that's important. Do you pair program? Do you code in pairs?
Sometimes.
Sometimes. So we code at least half a day or usually more than that. It's very tiring. The quality is very high, and it's very. I don't trust myself, so I need a colleague to code with me. So these are some of the principles and values that we're going to see. Which principles are part of the XP principles? What principles do you recognize? Feedback. From XP?
Team building.
It's not really. It's perhaps it's also XP, but it's not one of the core values. Simplicity, communication, and feedback are definitely from XP. And the others are a mixture of principles and values. So, one of the core principles is that my code should not surprise a reader, either myself in the future or any colleague that has to maintain my code. So, when I am done writing the story, the feature, or just the class, I used to read my code again and ask myself whether the code really expresses the intent. But when you read express the intent, it's not really clear what it means. But if you think in terms of surprises, is this code gonna surprise someone? Then you get more information about it. So something I do is I read the code I wrote yesterday, and that's a little effort and a lot of benefit, because just changing one name, renaming, or extracting one method, or inlining a method, it takes very little time, and the return of the investment is very big. This is one practice that I recommend, and I do it, and it's very valuable. So when you go to the work, take a few minutes to read the code that you wrote yesterday. This one, I think it came from Workuningham. Are you familiar with the less surprise? And of course, if there are no other principles, we want to keep everything simple. Simplicity is an overheard. Aliens in the code. An alien in the code is when you make up a name, when you create a concept and you create a name in the code that nobody's talked about never before. Like it's a new concept, but it's actually sometimes it's a concept that exists somewhere else, but you are creating an alias for that name, and you are confusing everybody with the code. So you are creating a new name, and we call that an alien. And the power of the names is something that we developers sometimes don't recognize. And the way the brain works is the way we create the reality is based on concepts. So if you choose certain names, your design will be different to the one that you make when you choose different names. So even your classes, the objects and responsibilities, the names are related to all those things. And I don't know, what's your, you know what I mean by the power of names and the relation that they have regarding the design? So a method is an abstraction. Every time you create a method, you have to put it a name. And in the last couple of years, I've seen many people, because they read the clean code, and they like to have small methods, so they extract methods all over the place. I've done that myself. And then what I'm valuing now is the cost of undoing that method extraction. So when you see a long method, it's quite easy to realize that there are perhaps two responsibilities in method, so you can extract one. But it's quite easy to do if you have proper tools, and it might not be very easy. But when you have one single responsibility scattered around multiple methods, then that change is harder. So if you extract the method too early, it might be the case that there are several methods that must be combined in order to achieve the single responsibility. So what I'm meaning is that before extracting methods, just because they are long, I try to wait a second or a few minutes or even a day before extracting, and make sure that the abstraction that I'm creating is the right one, and based on the name and the knowledge that I have about the domain. So don't extract the method too early. That's what I would say to myself a few years ago. And I like this sentence by Sandy Metz, that the duplication, what we understand by duplication, is not necessarily what the dry principle wants to explain. So dry is not about code that looks the same. So it might be the case that there are two blocks of code that are identical, but it's not necessarily the same concept. It might be casual, incidental quality, or I don't know how to put it, but the fact that the code is equal doesn't mean that we are duplicating concept knowledge. And sometimes it happens. So that's why some people say, wait until you have the same thing 3 times before extracting the duplication. And regarding names, the name of the method has to be more abstract than the body of the method. So imagine that there is a method validating some parameter. If the parameter contains an empty space, it has to throw an exception. And the method name is throw an exception if contains empty. Seems to be readable, but there's no abstraction. So you are just stating in English what the method does in Java or whatever. But it's basically the same level of abstraction. You know what I mean? So in those cases, my point is that perhaps it's not the right time to extract a method, or not the right name. So the name has to be more structured. And the same principle applies to functions, to tests. A test method is also a kind of abstraction. So the name of your test cannot be 2 plus 2 is 4, or returns 1 when the result, the input is whatever. Because that's a concrete thing that you can read inside the test. So the name has to be more abstract. It has to be business rule, behavior, those things. Mm-hmm. Is there anything in there that you want to talk about, or you can go to the next slide?
Just wanted to point that maybe sometimes it's complicated to find a good level of abstraction for some functionality, and how can you learn that? I mean, it's not something that you can learn from a book or something maybe, or just experience, or what do you think? How have you found the best level of abstraction for your code?
what I realized is that the three things go together. Before this, I kind of thought that there were different things, and they are iterative. Like the four rules of simple design, they are by nature iterative. So when you remove duplication, you have to think of a good name. So you are creating an abstraction, and then you have to review again the name and whether it's actually duplication or not. So it's a combination of all of them. I always go back to the less surprise principle. So that's something. There's nothing other. There's nothing more than that. I always wonder if the code is gonna surprise the reader. If the simple, because abstractions sometimes introduce complexity, or perhaps very often they introduce complexity. So, but they also hide in, for example, abstractions hide dependencies. If you are using a dependency and you are calling that dependency, that method of the dependency in several places, something you can do is create a method that with a single line that calls a dependency, and then you are hiding that dependency in all the places in your class. So you only have one method depending on the other method on the other class. And that code is more stable or easy to maintain. So you have class A depending on class B, and class B has a method, and class A is calling that method in many places. So something you can do is create a private method that is a delegate that then calls B. And that's an abstraction, and it will help you change the dependency in the future. So that's one trick.
Mm-hmm.
Do you have any example in mind, perhaps?
Another abstraction, or people doing some kind of code to, I don't know, abstract an if or something like that, and then you have like a cascade of abstractions that you don't know even where the real value of the code is. You have to like navigate through all the abstractions, and then you go crazy. This is something that I found, for example, a lot in PHP design that we do in my company, but we do also Golang also, and we don't have those levels of abstraction. I find it simpler. So I was wondering, what do you think about that?
Yeah.
But also how to review a code and tell someone, hey, your abstractions are wrong, or something like that. Or they should be simple. Maybe something like more, I don't know, personal, or how do you feel the code? Is it more about, I don't know, feeling?
Yeah. I like this sentence by Ken, like first make it work and then make it pretty. And then often when you work with people, you see that that's not the case. It's not what the people do. 2 days ago, I was working in one company as a consultant, and they wanted to extract the decorator with the AOP. All of a sudden, doing a single step. I think it was the first implementation they wanted to have AOP and interception and those things. And I said, wait, let's create a function, let's make it work, see how do we like the code, and then perhaps if we have to use this artifact more times, it's more convenient to convert it to a decorator and those things. But we only have it once, we don't want to introduce the complexity. So I think the fact that we want to abstract too early is one problem. And that's why refactoring is so important, because the right way to add an abstraction is when you have enough knowledge. And sometimes you have the knowledge when code is already live into production, and you have been releasing several times. So there is a slide I have in here about refactoring. So the knowledge that you gather when time goes by and people are using the software and you have to make changes in the software, that's the right time to make many of the abstractions that we often put in the first place. So what I do is refactor, create the abstraction in the refactoring stage more than in the first iteration.
Mm-hmm.
So that's why refactoring is so important, because you are learning about the code and you are getting about the business, And if you don't go back to the code and transfer that knowledge to the code, you are kind of losing money or losing knowledge. And this is why refactoring is so important. So it's not because we want to have perfect code when we refactor, it's because we want to enrich the code with knowledge about the business and the problems. And that's reason number one for me to refactor the code. It's not to make it pretty.
Sorry, question. So you're saying that initially you go for something that works, right? And do you often push this to the repository, or you after that you keep on working on that to refactoring, then push?
It depends. That's why we are talking about principles in the small. If the thing that I just created say that I wanted to have fast feedback about implementation, and for that reason I decided to add a Boolean parameter to the method. But I know that's really bad, and because then it means that the function is doing two things, and I don't want that to be in the code base. So perhaps I do that for a few minutes, see if my idea works, but then before pushing that I change the method. So as to not spread that method through the code base. So it depends on the code smell, and it's a trade-off in between. But sometimes I prefer slightly longer methods than really small methods with perhaps growing abstractions.
So it's okay to end up with such a method in the master branch?
Yeah, I think so.
And how do you deal with, for example, you did this thing and someone else is doing the code review and he has good points like this should be broken up, or the design is not perfect. So what is the argument? I'm going to do it later. I want to push this now because I don't want to create a too big commit. Because this is often, I hear this stuff many times a day, and it's usually 20% of such cases ends up never refactored at the end. So how do you deal with this?
If I know the name, if I know how to create the abstraction and I'm sure about what I'm doing, then I do it. I extract the method. But I'm talking about the case where you don't really know how to, what's the name the method should have. And so in those cases where you're not sure about responsibilities and names, it's better to wait. If you know the name, then go ahead and do it. In our context, we are doing pair programming every day and mock programming also every other day or something like that. So the code review is ongoing all the time. It's constant code review. And so we have a fast feedback about the design, and we don't have this process where you send your pull request to someone else. But if that happens and the person knows how to split the method, perfect, that's very good. Then you can do it exactly at that time during the code review. Yeah, I'm not talking about being lazy and deferring and introducing technical debt. I'm talking about if I'm not sure, I'm not gonna pretend that I know everything and I can create some beautiful code. Because then the cost of undoing those changes is very high. So I used to think that extracting a method was for free because the tools are very powerful. So I went creating methods, or even classes. And then what I'm realizing is that it's not for free. When you have to undo the change, it's quite expensive. This one, the behavior factors, is sometimes where you don't know what to put a new functionality. You have a function, and what you want to do, you implement a function, but it's not sure which module or class is gonna be the owner, the container for that functionality. When that happens, Corey Haynes said in the book that perhaps you are missing one abstraction. So perhaps there's one concept that needs to emerge, and I think it's a very good idea. So every time you feel the need to push the method into the utils or helper class, perhaps you need to create a new concept where to host a new function, a new class or new module or whatever. I think it's a really powerful idea and very interesting. That question that, so where do I put this function? And this is also very interesting. You have a block of code and perhaps a long line, string plus some other calculation plus some other calculation just to join a string or to process a string with different chunks. Sometimes explaining variables to name those smaller operations give you a hint about the because every time you introduce a name, you are adding a concept, and then you get a better understanding of the design, and you decide to create a new class or a new method. And so explaining variables are also very valuable and very cheap, unless you introduce an alien. So if you're going to create an alien in the code, then it's going to be more expensive. So it's all about naming, abstraction, and application. They are all together. Any other question or opinion? Okay. Do you have classes that have 5 dependencies? And you do dependency injection?
20.
Well,
That's exciting.
I don't know what to say. Sorry for you.
Yeah, I feel the same.
So, when I have more than 2 dependencies in one object, that is a code smell for me. Because Sandy mentioned she talked about the context. The context is the dependencies of the object. If you have an object without dependencies, you can test it easily, and it's easy to reuse and to test. But if you have 5 dependencies, if you need to mock any dependency, the test is going to be like this, mocking that. It's terrible, it's really hard. And if you have 20, you just throw through the window, jump. So as a rule of thumb, I try not to have more than 2 dependencies in my objects. And of course, avoid a graph. So if there's a circle in the dependencies or something like that, it's a really bad symptom. It's very useful to use those tools that build UML for you from the code and show you the dependencies between the classes and the packages. Because the dependencies, they are like this, like the hands in the picture. You're going to have a hard time maintaining the code. So you probably change one thing here and many other breaking things all over the place. So when you draw those pictures, ideally the directions should be clear. Are clear about so there are single direction of the dependencies. Not everything is pointing to
each other.
Yeah. So this one, composition, is a way to avoid coupling. Because in inheritance, do you use inheritance much? Like, do you prefer inheritance, composition?
Composition over inheritance.
Mm-hmm.
Depends. Depends on project.
Mm-hmm.
Also depends on the language. Like in Go, you don't have inheritance, or you just can have composition.
what I found in languages like Java or C# is that inheritance is okay for the framework, for the layers in the delivery mechanism. For example, it's very useful to have a class that you can inherit to a controller, for example, to get the request and the response and those things. That's very convenient. But in the core, in the hexagon, in your business model, I cannot find of cases where inheritance is really useful. Very, very few cases. So I try to refrain myself or my colleagues when someone wants to use inheritance. It's like a code smell. If we are inside the hexagon, inheritance is like a code smell. Of course, we can reason about it, and perhaps it's the best choice, but it's like an alert. And the other one, I would tell them ask, we're going to talk about it later.
I have a question, sorry.
Yeah.
Well,
one thing about that you already said is that I sometimes I read about the final keyword on classes, and the man says something like, if you don't want to promote inheritance, just put the final keyword, something that we are not so used to, in order to make think the other person that comes to these classes and have the temptation to inherit from it. So it's just a thinking point. Hey, this has a final, you shouldn't inherit from that.
That's a good point. Actually, the creators of C#, they decided that the methods are final by default. So in C#, you cannot override the method unless you explicitly say that the method is virtual. And sounds good, but it's shit, because then you cannot mock objects. So in C#, it's very common that we are doing testing or TDD, and you run the test and it fails, and the framework says this method is not virtual, and then you have to go to the method and make it virtual just because you want to stop a method or mock it out. So sounds like a very good decision, but it's not. That's one principle that I don't have in the slides, but it's restrictions. I think one of the very good things about JavaScript is that the author didn't have enough time to put restrictions on the language. It was bad in one hand, but on the other hand, you can use the language in the way you like. There's no silly restrictions. Like in Java, the fact that you have to say this method is going to throw this exception, that's really annoying. And it's a restriction that you are adding to it. So there's always time to add restrictions, but the cost of undoing or removing the restriction is very high. So it goes again back to the cost of removing stuff that you add to the code. But it's something that I value a lot.
Yeah, I just wanted to, about dependency number, if your code needs some logging and instrumentation, like typically I am passing like the metrics and the logger everywhere, and it's kind of crazy. I just have 2 dependencies for that, and then I add that one collaborator or something like that, and then I just have 3, right? So how would you fix that? Any idea or?
Mm-hmm. Well, those are infrastructure components or dependencies like logging or security and those things. A good idea is one way to solve it is using a decorator or some kind of AOP, so you don't have to call the logger from your business object, but you can do it in a different layer in the system. I try not to have the logger everywhere in my business classes. So I like the decorator pattern for those things. That's one solution. And perhaps you can group several dependencies behind a facade. So you can create a facade for infrastructure that is hiding several things that, from the point of view of your business class, are just one single responsibility.
Mm-hmm.
So there are several ways, but I would consider that to be kind of smell, because of having the logger everywhere sounds like it's going to be hard to maintain. But, well, we will need to see some code, but I guess. And this sentence by Curry is very interesting. So you have class A and class B, both are depending on class C. So you have the two dependencies, and one way to avoid the dependencies or reduce the complexity is to invert the dependency, especially if A and B are the same type, the same hierarchy. What you can do is that C depends on the abstraction that A and B are implementing, and then you reduce the number of arrows, dependencies in between objects. And very, very interesting approach. But the direction of the dependencies is very important for the garbage collection. So if there's one object that is being used by others, the garbage collector is not going to be able to fill the memory. In the books, they talk about objects, but what we are reasoning recently is that dependencies, data fields, like an instance variable, is also a dependency somehow. From the point of view of a method, a field is a dependency. It doesn't have to be an object. And also the same principles may apply to the fields data. So Ken Beck talks about local consequence. If you have a function that doesn't depend on anything from the outside, it's a pure function, it only depends on the arguments. It's quite easy to change, well, if it is a short function, right? If it is not 1,000 lines of code, it's quite easy to change and fix, and you're probably not going to break many places in the system because it has not many dependencies. So we favor stuff that where the consequences are local over global or higher or bigger scope consequences. For this reason, we now prefer pure functions that methods sometimes. So if we have a class, there's a public method, and then we end up with a few private methods. And the private methods are depending on some fields in the class. Sometimes we convert the methods into pure functions by sending the fields as arguments to those functions from the public method. I don't have a code example in here, but and even to enforce that, sometimes we use the static word in the function just to make sure that no one will access the field from the class. Sounds a bit weird at first, but when you know that the function is really, for example, it's a query function where you just want to have a result based on a calculation, and you need the fields of the class for that calculation, we'll find that sending the data fields to the function is better in terms of maintainability in some cases, because when you need to move the function to some other class, if you decide that you need to extract a new class, it's very easy to do. And the function is very easy to understand. So it's by combining the principles of managing dependencies and the local consequences, we are sometimes creating private static functions inside our classes, which is something I never did before, and it's working very well for us. It's not always, it's not black and white, but sometimes the private static is working well, especially when it's a query, it's just a calculation, and really doesn't make sense to use it like a closure, accessing data from the outside. What do you think? Is a weird idea?
I've done it sometimes.
Mm-hmm.
Maybe influenced by functional programming, which is more or less the approach.
Yeah. Next slide is about state. I think that the good thing about functional programming is that we are more aware of how bad the state and changing the state is. The good thing is that we can apply many of those ideas into the object-oriented world. So the fact that you have a class doesn't mean that you have to have the data all over the place in your class that we are discussing. And that's a good point, and something good that we are learning from the functional programming world. We prefer side effect code, side effect free code, because it's easier to change, and there are not that many defects usually. And for that, we have very good techniques in the object-oriented world, like the value object, that I think we are not using enough the value object pattern, which is it's very, very nice. You know how it works? You know the pattern? Does someone want to explain how it works?
It's quite simple. It's like a DTO, but if you want to modify its state, you don't have any setter. Instead, you will have to create a new instance of that. And it's like DTO is for only representing data, but value objects also have behavior. And it's quite useful to model some kinds of things of your domain model, maybe like, I don't know, chair or something like that. Something silly, something that doesn't have an identifier. Is the difference between a value object and an entity, and more or less, that's it.
Yeah, the string, in all the languages that I know, the string is immutable and is a kind of value object. Any operation on the string returns a different string. It doesn't change the original. And that is saving our life. Imagine that some languages decided that the string is not immutable. That would be a nightmare for us. But fortunately, it's a value object. And we can do the same in many of our objects, like if you have a color or a coin or some kind of concept that by nature doesn't have an identifier. So if you are going to compare that object to another object, you just compare by the value, not by the ID. For those objects, it's a good idea to model the operations so that there's a change, you return a new instance of the object. So if you are going to mix one color with other color, you're not going to change the original. The result is a different color as a result. And this is something we are not using, or at least I go to many companies and see many code bases, and there are no value objects in the code. And that's a way to avoid state and to avoid mutability. Perhaps you have some state, but you are not changing the state. That's also very interesting. For the same reason, if you have a function that is doing some calculation, please do not change the state of the system. Like if the function is not void, and you can read the signature and see that it's returning something, then if the argument is an object, then don't change the object inside the function. Keep the code in outputs. The system doesn't have to change. Make the function repeatable. Don't go to the database. Don't change anything in the system. Just return a value. So this is the command query separation. My principle is that in the core, functions or methods are actions or query. So if it is an action, if I am going to modify the argument or cause any other side effect, then the method has to be void. It has to clearly express my intention. But if I'm returning something, then the function is not going to be changing anything. In all of the hexagon, for example, in the outer layers, this is not easy to do. For example, sometimes you have to create a new entity, and as a result, you want to have the ID. Then it's a mixture of command and query, and it's really hard to avoid it. But inside your hexagon, it's quite easy to do. And then you avoid surprises. and you are sure that the system, the state is not changing, it's very valuable. So I try my function to be one or the other. This is familiar? You familiar with this? And for the same reason, state changes, I avoid setters as much as I can, so no setters if possible, and also limiting the getters, because the getters, this is related to the law of Demeter, the don't ask. If you have getters all over the place, then chances are that people will break the law, the don't ask principle. Sometimes you cannot avoid it, but the getters are not for free. They have also a cost. And I like this sentence that says that when you need to express state, especially in the case of a primitive, when you're creating a primitive in your core hexagon, in your domain, you might be missing some concept, some abstraction. Actually, in the core, I think we should not use primitives very often. Primitives are okay for the outside world. Like you receive some data via HTTP, of course you need to use a primitive. Once you enter the code that you control, why are we using so many primitives? I think we are missing abstractions concepts. It's okay for the first iteration, perhaps, and then once you refactor, you can avoid the primitives. Solid. I'm not gonna talk about solid. Does everybody knows about it? Okay. That's why I'm not gonna talk about it. And just 2 more slides about the things that we have learned applying hexagonal architecture and domain-driven design is how to use data transfer objects. In the past, we used to have a data transfer object with many fields, but you never knew which fields contain data, because we were using the same object for many different things. So in one action, you have the object with 20 fields, and you have to ask whether this field is null or false or zero, just because you are not sure, because it's being used, the same data transfer object is being used for many different actions. So in the end, you don't know, you cannot trust the object, and you have to be defensive about the contents. So what we are doing is that every action ends up having its own data transfer object, and we believe that they are not intended for reusability. They are intended for data transfer and nothing more. So we try not to reuse the DTO. And one good thing is that it is a way to distinguish domain objects from data transfer objects. Sometimes we grab the data transfer object, and this is very related to data binding, because sometimes we are tempted to use a data transfer object as a data binding object in the view, especially in native applications. Before doing that, we prefer to grab the object rather than binding. Okay. Yeah, with only 5 minutes, perhaps we can go for questions. There are 3 slides. And this one is quite heavy, so I'm going to skip it. Cyclomatic complexity. Do you know about the transformation priority premise? No? I recommend you to Google about it. It's very interesting. So the other day I was working with people, and they had some kind of structure with 3 or 4 items, no more than that. Rather than having a class to express that concept, I think they use a list or an array or something like that. And then, because it was an array, in order to iterate and get the data, even though it was only three items, they use a loop for it. Because if it is an array, you want to use a loop. But then you are adding cyclomatic complexity, and in reality, you're never going to have more than 3 items in this particular case. So the point is just do the thing 3 times. If these 3 lines of code that you are going to write, no problem. Don't add a for loop when you don't really need it. Sometimes we see if it is an array, we need to iterate with a loop or a map or something, and perhaps it's not the case. So cyclomatic complexity doesn't come for free. You don't have to use it just because the structure seems to be iterative or something like that. And I knew there was no time for everything. So these are more topics that we can talk about during these days. Recommendations and principles and values about this. So if you want to talk about more principles, face-to-face, having a beer or coffee, I'll be happy to talk to you. And any question or any final thought?
What does mean the third one?
There are some people, I've seen code where there's a recursion, but the call to the same method is not in this method because someone abstracted the method and created a new one. So the nature is recursive, but you don't see the recursion. You have to jump several methods to see that it's actually doing recursion. Mm-hmm. So if it is going to be recursive, my principle is like keep the call to itself in the same place where you can see it.
Isn't recursion a smell in most of cases? Because I think I have read it somewhere that many people consider recursive code, especially high-level code, a smell because it's sometimes most of the times it's difficult to follow or to unwrap and follow the concepts. In
the transformation priority premise, Bob Martin recommends recursion even before loops. Mm-hmm. So I think there are problems that by nature are recursive, like a head-tail problem. Yeah. For those cases, naturally recursion is more simple than iteration. So in that situation, what I would think is about simplicity. Simplicity versus abstractions, names, those things. Sometimes there are very good exercises where the recursion is a very elegant and simple solution, but a loop is really hard to implement. There are katas for that, like the word graph kata is very interesting to practice the powerful of recursion. Okay, so anything else? I'm sorry for my sluggish English. I've not been talking English in a long while, and thank you for being here. So, if there's anything you don't understand, any of you guys, just let me know and I'll repeat. So the way we work, I didn't introduce myself. So we are a small software company. We write software, and the way we do it is that we pair most of the time we are pairing. We are 2 people working together, and sometimes we are more than 2 people, 3, 4, or even 6 people working together. So when you want to implement your idea in a certain way, if your reason or if your argument is that I like it this way more than your way, it's really hard to find an agreement. So, and that happens very, very often because you smell that the way that your colleague is proposing is going to be a problem, but you perhaps don't know how to explain it. Why is it going to be a problem? I mean, it's a battle between I like it and you like it, so what do we do? And for this reason, we are more aware of the principles and the rationale behind our small decisions. And this is why we try to conceptualize or explain everything in a way that is logical. Like if I was coding on my own, I don't have to explain anyone why am I choosing this way or the other way. But when you are pairing, that's important. Do you pair program? Do you code in pairs? Sometimes. So we code at least half a day or usually more than that. It's very tiring. The quality is very, very high, and it's very. I don't trust myself, so I need a colleague to code with me. So these are some of the principles and values that we're going to see. Which principios es el que quería hablar? Principios del detalle pequeño de la decisión que tomas con cada línea que escribes de código. Adelante, ¿no? La idea es que uno sea consciente de esas decisiones para no tomarlas de manera inconsciente y luego que las consecuencias te exploten, y que en nuestro caso sepamos explicarle a otra persona por qué tomamos esas decisiones, cuáles son nuestros principios y por qué son esos. Y el motivo por el que nos preocupa tanto a mí últimamente es porque hacemos pair programming todo el tiempo. ¿Habéis visto el vídeo de Atlassian, de Pune?
Sorry for interrupting, just a quick question. Is this talk that should be in English?
It should be in English, but before you were here, I asked a question.
So I'm the only one.
No. Then I switched to English.
No, sorry, don't bother because.
No. Officially, it was supposed to be in English, so we can do it in English. Thank you for letting me know. Now I'm going to be a little bit more slowly, but I also, pues, claro, no hay problema, pasar. Pues son ideas que he traído principalmente de estos libros y algunos que no está ahí, y también gracias a los años de experiencia en la batalla, teniendo suerte de programar con gente de la que aprendí mucho. Esto va sobre principios de diseño, pero no a nivel de arquitectura, de sistemas de infraestructura, sino va de que cuando uno está programando, siempre está tomando pequeñas decisiones sobre, bueno, esto aquí uso un bucle o lo hago recursivo, pongo un if else, pongo un switch o hago polimorfismo. Hay un montón de pequeñas decisiones que a veces ignoramos, que en realidad sí que estamos tomando. Y el ser consciente de ellas hace que tu código al final sea más mantenible, ¿no? Son detalles muy, muy sutiles, pero que acaban teniendo un impacto en el código. Sobre este tipo de... Tenemos bastante tiempo y, entonces y además como es en español, me va a sobrar tiempo. Entonces lo ideal es que sea participativa la charla en cualquier momento, que sea una discusión. Quizá, de hecho no me importa si no da tiempo a ver todas las diapositivas, siempre que sea enriquecedora, que nos aporte la discusión. No es porque no voy a correr para terminar de ver todo, ¿vale? Por supuesto, muchísimas gracias a los que han organizado esto y a los sponsors. Si alguna vez organicé un evento de este tipo, pero es que es un trabajo titánico, así que gracias a todo el mundo. De las cosas que quería hablaros, digamos que la mayoría están inspiradas en estos libros y en estos autores. ¿Conocéis los libros? ¿Os suenan? Los autores quizás sí, algunos de ellos no.